So today we're going to talk about how do you wire and program up a 2-pin button using CircuitPython. So wiring up a 2-pin button is pretty easy. Obviously you need a 2-pin button here. I just have a simple arcade button that runs on 2 pins. You might have a 2-pin button that bridges across the center of your breadboard here, but effectively it's the same deal. So I'm going to add a 2-pin button here, and I can choose any random ones that I want. I'll throw it under there. Now we have to get power over this button to actually read this. We're going to wire this button in pull up mode because pull up will make reading a sensor far more reliable to electrical noise than a pull down button will. So let's grab about 3.3 volts here. We'll run it to a common power rail, and we'll also grab a ground. We'll run this to a common ground rail. Now we need to actually do the pull up side of things. So I'm going to go ahead and grab from my 3 volt here, and I'm going to choose a different rail than the current rail that my button is connected to because I need my power to run through a 10,000 ohm resistor for this. So I'm going to take my 10,000 ohm resistor, I'm going to wire it in on one side of my button here. So one lead is coming out to my 3.3 volt jumper, and the other one is going into one side of my button. On the same rail as that top rail, I'm going to connect another jumper wire, and I'm going to send this back to my digital port for my signal. So if I were to look at this circuit now, I'm coming from 3 volts, out of 3 volts through a resistor, and back into my digital port. So reading the port at the current moment would read high. And in order to make it read low when we push the button, we're going to go to the bottom rail of this 2-pin button, and we're going to go back to our common ground. So now, when we're not pressed, it's running 3 volts directly into our microcontroller. When we press this, it's going to skip reading into our digital port here because electricity always likes to go to ground. And we're going to run it through the button, and we're connecting these 2 contacts together, and then now we've got a closed circuit off. So let's actually program this. Coming over to the computer here, the first thing I need to do is I need import board. I also have to import time. And the last thing I'm going to import is digital in-out. So I'm going to say from digital in-out, import digital in-out, direction, and pull. Now let's actually initialize our button. We'll create a button, and button is equal to digital in-out with a capital, board.d1, because that's where I plug my button into. We'll say button.direction with a lowercase d is equal to direction.input. Now this direction is capital D and all capital inputs. I'm also going to do button.pull with a lowercase p is equal to pull uppercase dot up, all in capitals. And that's how we wire up, or that's how we program the button. Super simple. Let's actually get into a while true loop here so we can actually read this thing. We'll say button_state is equal to button.value. So this line here is the one that actually grabs the value from the sensor, and we assign it to our variable button state. And for now, I'm just going to print button_state. And then I'll add a tiny time.sleep of 0.01, so maybe 10 milliseconds. The reason you have to add a small sleep in your sensor reading is if you don't, you're going to get something called bouncing on your button, where when you press it, it will not read it super reliably because your CPU is able to read so fast that it can't actually have enough time for that electricity to pass through your button and all of its wires effectively. So let's go ahead and save this over. Oops, I need to plug in my CircuitPy drive. We'll save this over. And if I open my serial port, you'll notice that it's constantly reading true because I haven't pushed the button yet. But as soon as I push the button, it now starts to read false. So true, false, true, false, true, false, true, false. That actually isn't very interesting right now. Let's actually do something with this. So instead of just simply printing button state, let's say if not button_state, we will print pressed. Otherwise, we won't print anything. So let's go ahead and save this over. And now you'll notice that nothing is printing until I come up and actually push the button. and it says pressed. Now you'll notice that it presses it multiple times. You can't just use this for once in a time. So for instance, if I were to say counter is equals 0, and I'll say counter plus equals 1, and we say pressed counter times. So now if I were to save this over, it's going to tell me how many times it thinks the button was pressed. So if I were to push this button here, you'll notice that when I press it lightly, it counts it as almost 6 times to be pressed. If I press it again, it's almost 19 times to be pressed. So when you push and hold it, it will count as being pressed. Making a toggle button is a little bit different, and we'll talk about that in a later video. One last thing that's interesting to note, just to explain how these buttons work, if I were to take these quick pins out, and all I need to do is just tap these 2 buttons together, and it counts as being pressed as well. So that's literally all the button's doing, is just taking 2 wires and it's connecting them together in a circuit. So I hope that video was helpful for you in wiring up 2-pin buttons. Let me know if you got any questions in the comments down below. And best of luck on your projects.